All right, difference of two squares. Factoring the difference of two squares. This is just like all the other ones, except when I see two terms and one of those being an x squared, I know that my job becomes really easy. Because it means that my middle term, the term that goes right here, if this were right, is going to be a 0. So that means that both of my parentheses, or both of my binomials need to look the same in order for it to cancel out. All right, so let's start looking at some examples. X squared minus 121. In order for them to look the same, they're going to have to be perfect squares. What is the perfect square for x squared? What times what gives me x squared? X and x. What's the perfect square for 121? What number times itself will give me 121? 11. Now I want to end up with a term of 0 in the middle, so it's going to be plus, minus. Done. All right, next example. 9x squared minus 49. Again, I'm looking for perfect squares, things that will cancel each other out. So perfect square for 9x squared, perfect square for 9 is going to be 3. And then I want to have an x. Perfect squared for 49 is 7 and 7. I want to get a term of 0, so I'm going to do a minus and a plus. Difference of squares is a very important type of factoring. It will be used in upper level mathematics quite a bit. So you need to make sure that you recognize this case of factoring whenever it pops up.